welcome to a new unit, Unit 11, Data Analysis and Probability. We're going to look at different ways of displaying data, starting off with Lesson 11.1, using stem and leaf plots and histograms. Now these are used to display data. You gather information from perhaps a survey or an experiment, and you want to present this information in a way that the average person can look at it and understand what's what. And these are different ways that we can do this. We're going to start off with the stem and leaf plot. The definition is kind of weak here. It says a stem and leaf plot is a data display that organizes data based on their digits. We break the numbers down into what we call stems and leaves. Each data value is separated into a stem, which are the leading digit or digits, and a leaf, which is always the last digit. And I'm going to do an example to show you. I've already got it kind of written out here a little bit. It says the number of passengers on each of 10 city buses is given. Display the data in a stem and leaf plot. Now notice here I have kind of a lopsided capital T here. This is where I'm going to put my data, and I've entitled this Bus Passengers because that's what it's talking about. Now I have 10 numbers over here, but the very first thing I'm going to do is I'm going to put them in order from least to greatest. So let's see, the smallest one is 12, then 14, then 17, then I have two 20s, I'm going to list them both, and then 23, 25, then I have two 35s, hopefully I didn't skip something here, and 39. Let's see if I count up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now notice here that my leading digits on each of these 10 numbers ranges from 1 to 3. So that's what I'm going to put onto the left side of this dividing line. I'm going to put the digits 1, 2, and 3. Now, those are the stems. Now the leaves are the units digits for each one of these, which is why I put them in order. I want them in order over here. So for the 1, I have a 12, I have a 2 here for the 12, a 4 here for the 14, and a 7 here for the 17. They all have a lead digit of 1, so I need the 2, the 4, and the 7. So the 2, the 4, and the 7. Those are my leaves. This means 12, 14, 17. Alright, these are gone. Then I have my numbers in the 20 here. I have 2 zeros, a 3 and a 5 for 20, 20, 23, and 25. So I take the zeros, the 3 and the 5, the 0, 0, 3, and 5. And I have these guys represented. This is 20, 20, 23, 25. Now my last 3 numbers are all in the 30s. 35, 35, 39. There's my stem of 3, so my leaves are 5, 5, and 9. 5, 5, and 9. Notice how I kind of line everything up this way vertically as well, both horizontally and vertically. You need to be neat with these, and that is my information. Now, they will occasionally put a key down. Since the first number is 12, you may see something like 1/2 says equal to 12. Now, I have been out of college for a long time. I graduated with my master's in 1982, so it's been over 30 years. I took 2 classes of probability and statistics as an undergrad and 2 classes of probability and statistics in graduate school. And maybe I was shown this in my college days, but I have certainly forgot it if I had been shown this. I don't remember ever seeing stem and leaf plots until I became a teacher and saw it on the math proficiency test years ago. And I had to look it up in all things. I looked it up in a pre-algebra book to find out what a stem and leaf plot was. And so here's the first example. Okay, here's another example involving stem and leaf plots. Let's show the grades on a history test for 2 different classes, Class A, Class B, and a stem and leaf plot. What can you conclude about the grades? Well, you can see that the low grade was 72, the high grade here was 91. We can see that the low grade here was 71, the high grade was 94. What I see that kind of stands out is that Class B had 1, 2, 3, 4, 5, 6 students get A's, whereas Class A only had 3. So my conclusion would be Class B did a better job overall. They had less C's and a whole lot more A's. They did better on the test in Class A, based on this information. Now a stem and leaf plot shows frequency of each interval in the display, like in the 70s and the 80s and the 90s. The frequency of the interval is the number of data values. So like in this interval in the 70s, there were 5. In the 80s, there were 4. In the 90s, there were 3. Here, 3, 3, and 6. So that's the frequency, how many times it occurs. Now this is just one way to display data and show frequencies. Another one is a frequency table. A frequency table is another kind of display that groups data into intervals to show frequencies. And typically it looks like a double T chart here. The first column being the intervals, the second column being tally or tally marks, and the third one for the frequencies themselves. And so I've got an example here where it says Joan asked 20 classmates how many CDs they owned. Make a frequency table of the data using intervals of 5. So you can see here it goes down to 2 and up to 19. So if I go by intervals of 5, I would think I would go 1 to 5, then I would go 6 to 10, then I would go 11 to 15, and then I would go 16 to 20, and that would be my groups of 5 here. So what I'm going to do now is put a mark, a tally mark, for each one of these. Now here I have a 12, so the 12 would be in here, so I put a tally mark, and I cross that one off. I have another 12, put another tally mark, cross that one off, then another 12, cross that off, then a 2. Now the 2 is up here from 1 to 5. The 6, it would be here from 6 to 10. The 7, also there. The 18 down here between 16 and 20, 18. 19 also down here. 7 would be over here. Then a 4, that's up here. Then a 13, that would be over here. 13, then another 13. So normally instead of putting another slash here, what I usually do is I bring one across for the 5th one. And I have them in groups of 5, and that would be this one. Then the 7, then an 8, there's that slash again for the 5th one. Then a 9, then a 4, a 10 would be over here, and then 3 14s. 1 14, 2 14s, 3 14s. And I have all my tally marks. Now I just add them up. I have 3 here for the frequency, I have 7 here, I have 8 here, and I have 2 down here. And that's an example of a frequency table. Now, I'll tell you right now, when there's a frequency table lying around, there's going to be something called a histogram close by, and that's what I'm going to show you next. Alright, a histogram is another data display, and it also shows frequencies. Like I said, it goes hand in hand with the frequency table. It uses bars without spaces between the bars. So it's kind of like a bar graph, but it doesn't have the space in between them. The length of the bar shows the frequency, and the intervals have equal sizes, so therefore the bars are going to all be the same width. So I'm going to do an example here with some bowling scores. Rich's bowling scores in his last 15 games are as follows: 125, 158, 143, 177, 135, 117, 101, 158, 160, 144, 199, almost 200 there, 129, 122, 131, and 116. Make a frequency table and a histogram for Rich's bowling scores, and then we'll answer a question after we do that there in part B. So first, I'm going to draw this out. Now his lowest scores, remember, this is the interval, this is the tally marks, and this is the frequency. Okay? So since his scores goes down as far as 101 and up to 199, I'm going to go by jumps of 10 here. That's going to actually, you know what? Let's not kill ourselves with 10s. Let's do 20s. Let's go from 101 to 120, 121 to 140, 141 to 160, 161 to 180, and 181 to 200. I think if we do by 10s, we'll have so many bars it'll be very difficult for us to read. So we'll do in intervals of 20 here. So we start marking them off here. 125 goes here, 158, 143, 177, 135, 117, 101, 158, 160, 144, 199, 129, 122, 131, and 116. So we have 3, 5, 5, 1, and 1. All right, now I'm going to create a table. Or I have my table here. I'm going to create a histogram. So what I'm going to do here is I'm going to draw what looks like the first quadrant of the Cartesian plane here. This is Rich's bowling scores. Okay. Okay. Rich just walked by, and these are his bowling scores. Actually, these are probably his bowling scores when he was 10 years old. He's a much better bowler than that. So now what we're going to do is we're going to go ahead and create these intervals. We're going to have right here the 101 to 120. Right here the 121 to 140. Right here the 141 to 160. Over here the 161 to 180, and over here the 181 to 200. Now I have frequencies as high as 5, so 1, 2, 3, 4, 5, 6, that should be plenty, and this would be the frequencies, and I'll write this right here, frequencies. So now I'm going to make a bar that's going to represent this interval with a frequency of 3. Now what I'm going to do here is I'm going to go about halfway in between these marks, so the same distance here, up to 3. Now this is where it helps to have a steady hand or a ruler, and my wife is at home, so I don't have my ruler with me, and I'm going to go ahead and mark this in. Now for the next one, the 121 to 140, that's a frequency of 5. So about here up to 5. Now notice no space in between the bars here. Let's see if I can do it freehand without messing up too bad. That's not looking too bad. And that bar represents a frequency of 5. Then the 141 to 160, also a 5. The 161 to 180, that would be a frequency of 1 here, so I'm going to go to about halfway. There's the 1. And for 181 to 120, and one more 1 here. We have some guest mathematicians out there that are looking around, seeing what's going on. And this frequency table here, or excuse me, this frequency table here, and this histogram display the same data 2 different ways. Here with the tally marks and the frequencies, and here with the bars. But both of them serve the purpose of displaying data. Now it doesn't take that much to get to a point where you can draw these out yourself, but it does take practice, practice, practice.